Hi guys, welcome to Learn Electronics Repair. I have another power supply. This one's 700W ATX, active PFC it says on it, and this one apparently again has a short circuit of some sort. Let's stick it onto the light bulb current limiter. So here we go, one light bulb, set to limit. If it has a short, it will come on bright and stay bright. And that's exactly what it does. So we have another one with a dead short, probably on the input, on the high voltage side. Same as the previous power supply repair video. There can't really be any voltage in the high voltage capacitors in here because there is a short. We can check, I mean, don't get me wrong, we should always check, but I don't see how that would be the case. Having said that, it's the ones where you don't see how it could is the one that kills you. Yeah, so let's not be complacent. Okay, 4 screws as usual, and the top should come off this quite easily. Yep, there we go. I'll just disconnect the fan if it comes off easily. Actually, it's kind of oh, I see, it goes like a connector up here, which is up. I'll have to take the thing out and get the cable ties off this. Really? Yeah. How strange is that, as the fan connector goes up outside of the unit. But then there's a red one. Oh, I bet it's like a fan control, you know, rather than the power. I think this is just the fan control, basically. I'm pretty sure the red one here is the actual power to it. And that comes from a plug on here, okay? This has active PFC, the high voltage capacitors on this side. So this is the low voltage side, that much we are safe with. Let's disconnect this and get rid of the top. Okay, yeah. Disconnect that, and I'll have to take a few cable ties off this as well. Zip ties. Yep. That's out of the way of there then. Huh. It's typical. So the black one is soldered on here. Yeah, see, that's good engineering, yeah. So you can unplug that one. Oh, having said that, I'm sure it goes to this plug-in. I'm sure the black one does go here. Yeah, look. Look. So, guys, what's the point of that? What is the point of that? Why fit a plug which fits onto this board and then have another wire going to the same device which is soldered to the board? I don't get that. That is like beyond my capability of understanding logically. Why? Why? Okay. I mean, it's not even like an afterthought. There's a hole in the board for it that says JP1, yeah? Guys, that one is beyond me. Comments below, please. Right, so remove a bit of fluff and stuff, and that's our power supply. Nothing looks visibly damaged particularly. Bit of old glue, I think, down the bottom of these. Okay, you can see where the power comes in here. I think the bridge rectifier, yeah, is down there, but that wouldn't show us the high voltage if it's in these capacitors. But what it will do is show us if we've got a short on the input. Okay, there's a fuse down here, that one, and the fuse hasn't blown. Let's see, continuity. So this is clearly the power coming in. and there's no short there. So the short is further in than this. Then we have to take this PCB out and have a look. Let's see how we're going to do this. Have to remove a lot of these through the hole. Okay. And we have to unplug this one. What's that down there? Oh, I see. This is the active PFC. Okay. Fine. Why not? Yeah, why not? It's on the same... No, I think it's on a separate PCB actually. I think it's actually a separate board. So it's like it's been added to this. Obviously when it was made, but you know, it's like an option. By the looks of it. Okay, screw. Another one. I will say this power supply, if you saw the 800 watt Mars Gaming, look at the size of the transformer compared to that one. This is a 700 watt, yeah. This has the 3 transformers that it controls on the low voltage side. That's obvious from that to me. So main transformer for your main power rails, standby supply 5 volts, and then this one effectively the primary is on this side and it feeds the signal from the controller through the transformer to the driving transistors in the power supply, and they will be bipolar transistors, I would imagine, on this one, not MOSFETs. We could have a MOSFET driving the standby. All will be revealed. Well, all of this will be revealed, yeah. It's not one of them sort of channels, yeah. I'll leave that to those who are better looking than me. Awkward screw there. Okay, so it's loose. So that comes out. This comes out, yeah. This is the PFC. The awkward, out it comes. Okay. So from here then, we have the power coming in, the ground and the power going out. This is like either side of the diode, if you like, in the PFC circuit. One of these will go to the high voltage capacitors. So we can have a look now, but I don't see how there would be any voltage in this. Let's try. So one of these will be ground. I don't know exactly which one. So what I'll just do is check for any voltage between any of them. Nothing there, nothing there, nothing there. Okay, so there's nothing in here, there's no voltage. So we can handle this how we like now. We have one more screw. Probably under this lot somewhere. Okay, out it comes. So, easier to take apart than that Apple power supply if you saw the previous video. Okay, afterthought decoupling capacitor, filter capacitor. The first thing I noticed is that these wires fell off while I was dismantling it. They're actually very stiff. It's like they've kind of baked into this curved position. And these two, I'll zoom down for you actually, I'll show you where they go. You can see we have the red wire B+. This is the output from the bridge rectifier. Okay. And then we have, this is ground, and you can see actually that it goes down there to ground on the black wire. And then this is out. So this is basically into the inductor. You can see the inductor. This is where we find the diode and switching transistor, although there's 3 devices on this one. And then we have the out. which feeds the boosted voltage back to these capacitors. And the two wires that fell off actually come from here, okay? And to be quite honest, they're not very well designed. This is the output from the bridge rectifier, and this is where you feed the boosted voltage back. You'll see it better from the other side. Okay, so we literally have out there going to the PFC and coming back in here. Why they put these so close together, I really don't know. You can clearly see this one goes to the positive of the bridge rectifier, which is where you would feed into the PFC, and then this effectively goes to the capacitor. So soldering these back on wouldn't be a problem, but as soon as they fell off, it means we can easily check for short circuits on here. Call it a bonus, yeah? A subscriber asked me why I'm using this meter, my Fluke, rather than either the Aneng or the two Kaiwitz meters I have. The main reason I use this for this type of work is because of the way that the continuity test works. So with this one, if I set it to continuity, it's now reading in ohms, and I get a bleep when I touch the leads together. If I go to a diode junction, find the diodes, there's one here, and you don't get a bleep, okay? There's actually a 3-leg package, the two are connected together. It is a diode, okay? So in continuity mode, you do not get a bleep on a diode junction. If I go into diode mode, and we go to a diode junction the right way round, we get a bleep, one bleep and a reading of the voltage drop. But in diode mode, if I short the leads together, we get a continuous, okay? So that means that when I'm probing on the PCB, I don't need to look at the meter. I know diode junction, short. And none of the other meters I have work like that. I'd be very interested. In fact, I'm asking you guys, do you have a meter that works like that in continuity mode and diode test mode? And which ones are they? I'm very interested to hear. Because the Fluke is not a cheap piece of equipment, but that is just, to me, a bit of a no-brainer. They should all do this, yeah? In diode mode and in continuity mode, nothing on the diode, continuous for short. Okay, that's why. Now let's have a look at our PFC board. So we have two MOSFETs, probably starting with a K2SK. We've got two MOSFETs here. That one's got just a bit of a dirty mark, I think, on it. And then we have the diode, which is down here, which actually has 3 legs. So we can see, I've just been testing the diode, okay? If we go from the in to ground, there is no short, okay? And if we go from out to ground, there's no shorts. There's no shorts on this. The two large MOSFETs, we can have a look in circuit. So this looks like it's the gate. I'll put it to diode mode now. Okay, so gate open, effectively open. Well, it's reading a bit of a resistance, but that's fine. But look across the actual MOSFET, and we see a diode junction in the reverse direction. That's normal. So normally this is your positive, this is the negative. If you put it the opposite way around, this is what's called a parasitic diode. That's almost certainly a good MOSFET. Next one, looks like they're actually in parallel, these. Okay, nothing, and a parasitic diode. So it looks to me like these are okay. There's no short here, so this is not where the short circuit is. What I have noticed is that this capacitor has failed, it's bulged. This little one, which looks like a bit of an afterthought, visibly looks okay. Doesn't mean it is, but it looks okay. But this one's gone, so that needs to be changed. That's actually a 400 volt 10 microfarad. I'm pretty sure I can find something to put in there. So while we're here, we may as well change this, otherwise we'll probably forget. And then we'll probably regret that. So let's do this. Okay. I think it's these. Let's see. Yeah, that's one end of it. There's the other end. Yeah. Okay. So that's coming out. It's out. Yeah, you can see where it goes down there. It's quite compact, this thing. Okay. This is the Jun Fu, brother of Kung Fu, probably. That's find something to go in there. I have some. These are all pulls. I have a lot of salvage capacitors, and as long as you test them before you use them, really that isn't a problem. The ones I use a lot of, like the motherboard capacitors, I just buy 100 at a time. We'll just test this one. Normally with high voltage capacitors, the ESR is relatively high, and that's quite normal, so don't worry too much about the ESR of high voltage capacitors like this one. We'll see. So we can check this one, and we can check the one we took out as well. Yes, that one reads good. The one we took out, that is bad. Okay, that's bad. Let's look at the ESR. Even though it's not particularly important on these sort of capacitors, let's have a look. So this is the bad one. Just reads open. So it's a good one. Yeah, an ohm. As I say, they read relatively high, the high voltage capacitors, because the dielectric, the insulating layer in here, is thicker because of the high voltage. So that's a good one. While I have the capacitor removed, you can just see, if you look down here, this 3-pin device is in fact a diode. As I said, it's effectively 2 diodes wired in parallel. If you connect the 2 outer legs together, that's what you have. Okay, so it's a common cathode diode pair, and that's how it tested in circuits. That's okay. Well, that's replaced, taking note of the polarity. So the negative goes to where the black wire is here. This is the hot ground, and then the positive goes to the out, which effectively is the boost voltage from the PFC. So really this capacitor appears to be in parallel with the other ones, basically, the large ones here. Okay, so that's that. It's rather fortunate that capacitor was bulged, otherwise that could have been quite an interesting fault to find, but we don't have to worry about it now. But what we do have to worry about is the fact we still haven't found the short. So let's have a look. We know there isn't a short across the bridge rectifier. So the next most likely place for there to be a short is on the output transistors, the main driving ones for the power supply. I doubt the short's on the low voltage side, and the reason being that the light bulb comes on bright straight away. You would expect it to start up. Effectively, you would have to start it, by connecting this to a motherboard or to the ATX analyzer before the main power supply runs, and then if it was a short on the output, you would see it, in as much as it would draw a lot of current on the light bulb. But this isn't doing that. This is effectively as soon as you plug it in. Let's see which type of power supply we have. So we have 2 large capacitors. Are they in series or parallel? Well, I can see straight away by looking at them. They're in series. So this is one end, this is the other end. Okay. We don't see that same reading across the bridge rectifier because that is attached to here. In fact, the wires have fell off. So really we need to check for shorts here. And we don't have a short. But we do see like a diode junction. And you shouldn't do, especially with the positive to the positive end of the capacitors, if you like, in series. You shouldn't see that. Okay. So let's have a look at the output transistors. That's the next thing. They're quite large. You can actually see them. So they're behind here, basically. 1, 2. Okay. And the legs of those will be quite large as well, so we should be able to find them. Let's have a look. Yeah, one's here. 1, 2, 3. See like those square shaped legs or oblong? That's one of them. Well, that reads like a short. But is that the base emitter? If that's the base emitter, it may read like a short because this is driven from a transformer, basically. It's driven from the small transformer over here. That one. So you may expect the base emitter to be reading low. Just looking at it again then. So this is actually the base. Collector. Base emitter actually reads okay. So this must be the emitter collector. We have a short. I need to take these out. The other one is going to be here, a bit buried that way. Let's have a look again. That reads short. That one just reads short. Okay. So we need to unsolder the heatsink. I didn't quite hit record what I should have done, but basically I decided that the easiest way to do this was to remove the 2 large capacitors, and then I can unscrew the transistor and take them out easier. There's a third device on this heatsink down under here. I think you can probably just see the screw that's holding it to the heatsink there. So this will be the standby, the MOSFET for the standby power supply. I've removed the first one of these, and I'll show you on the second one how to do it basically. So because I couldn't see the negative, before I removed this, I put a little mark on the PCB and a mark on the side of the capacitor that went there, so I knew definitely which way it came out. Now I see how they marked. This one is more obvious. This is positive, this is negative, but we can see that anyway because this is where the wire fell off from the PFC. This is your boost voltage coming in, and this end is your hot ground. Okay, this goes to that black wire. You can use the meter and fold it if you like. I will take it as red. So let's get a bit of solder on this one. Leaded solder. Okay. Heat up the 2 ends. This one, because it's right up against the heatsink, is not easy to push that way. I've just moved a bit of wire that was trapped behind it. So this one, I'm going to kind of flick it outwards a little bit, finger behind it. And I move this a little bit. Okay. Wait till that solidifies, hit this end, and push it back the other way. This one doesn't have much room, but I will do it. Yeah. Just a bit like doing a 3-point turn, but in a tight space it's a 5-point turn. Same principle. Okay, wait till it solidifies. Back in again. Okay, now it's come off. So we have both capacitors. Okay. We can test these, but to be honest, these things rarely fail, and if they do, usually all the stuff leaks out of it and rots one of the legs off. Right. So the whole point of that was so we can get to the transistors. This is now much easier, so I will effectively unsolder each of the legs with a braid, and then we'll just take them off the board. I'll unscrew them first. Notice they have heat, well, it is like a heat conductive washer behind it, but it's also an insulating washer. So we need to put that back on. Sometimes like a little plastic insert, but in this case there isn't. Okay. just look out for them and make sure you put them back on. Can be just on one of them sometimes. So things like that you need to look out for. Those are not just for fun. There isn't one on that one either. Okay. Let's do some soldering. This one first. Okay. Might take a few attempts just to get the old solder off. That one's come out pretty well. Let's see, there's another one here. Yeah, that one is definitely on soldering quite nicely. Okay. Yeah, that leg's free. I can actually move it a little bit. That one I think also. So the last one's under here. And that one's free. Okay, let's take this out. Should now just lift straight out of the board without too much persuasion. No, it's well stuck to the heatsink. Okay. Try not to damage this washer, but if I do, I have spare ones. So we actually get the thing to come away. No, this one's like really stuck itself down. Yeah, it's got it that way. Okay, got it. Just checking the washer for any damage. You know, it's okay. So that's one of them. I'm just looking to see if this is effectively a little ferrite bead, but it's not. It's just a little bit of heat shrink. Otherwise, we need to put it back on. Now let's do the other one. I'm sure these will both be the same type, but I'll just keep that one where I know where it is. I'm really missing my vacuum desoldering tool. The handle will be here soon. When it arrives, I'll actually show you what went wrong with the other one, and it is to a good extent my fault. Okay, but you know, I own up to these things. If you do it, you have to own it, yeah. Okay, so this one is free. Okay. At least I know roughly how to get this one out. Yep. There we go. So these are quite easy to remove, as you can see. Let's have a look at them now. So this was the one nearest the end, this end. Let's see. Well, they're both identical. I thought they would be. They both have these little bits of heat shrink on, so we're not worried about that. They're not ferrites. The ferrite effectively acts as like an inductor at high frequencies. There's a reason for it. They're not just there for fun or decoration. Let's see if these are any good. Since I have the multimeter on my bench and I have it in diode mode, let's check them this way. Well, that reads okay. That's short. That one's short base collector. Okay. But it reads like a diode junction base emitter. This one reads okay base emitter. That reads sort of like a short. Yeah. So they've both failed. Now I need to see if I've got any of these or something I can use. It's 2SC3320. As I mentioned previously then, this will have a pulse width modulator chip on this side, the low voltage side. That could be it. I'd have to look up the part number, but that could be it. Okay. 750C, I think is the part number, that one. And basically, the standby, which is this device, this power supply, powers up via this diode here. Yeah, and probably another diode. It powers up this chip. And it will also power up the transistors, which I think will be here. But one could be the voltage reference for the opto-isolator. Where is the opto-isolator? Okay, this is probably the voltage reference, TL431, without looking. And these two bigger ones, yeah, they're too big to be TL431. These two will be an NPN and PNP pair probably, and these will be driving the primary of this transformer, the middle one. Okay, so when you power up, this gets 5 volts and these will probably get about 15 or 16 volts, and both voltages will come from here. Okay, the standby starts running, powers your motherboard and standby, and it does that via this purple wire here. Yeah, when you press the start button, the AT soft start, it puts a 0 volt, it grounds this wire, and that signal comes back into this chip, and then this chip starts the main power supply. Effectively, this is the pulse width modulator. It drives these two transistors that drive this transformer, and on the other side they will drive the base of the two transistors we've just removed, but they were short on the base. Yeah, now because there's a transformer here, this will almost certainly protect this chip from any damage when these went short. But what it won't do is protect the circuitry between the secondary of this and the transistors, and it's down here. Okay, you can see 2 small capacitors. They quite often fail, and if they fail, quite often it then blows the transistor up. So we need to check those, and there'll be some little diodes down here you can see as well. Yeah. So to test this source, I'm going to have to take this heatsink off now. But this will be easy considering that I only have one device fitted to it. Yes, I could remove all this lot to get to it, but you know, to be honest, I think it might not be easy just to get the heatsink off. So it looks like the heatsink's held on by a metal stud here and the 3 pins of the standby MOSFET. Let's remove those first. Or rather, let's desolder these first. Okay, those look like they're clean, and then I'm pretty sure there's a metal stud here. Yeah, it looks like it's there. And there might be one at the other end of the heatsink as well. Quite often this heatsink is connected to hot ground, by the way, which effectively to your finger is live-ish. It's live-ish. You'll get a shock-ish if you touch it. But that's just semantics, it will still hurt, yeah? So that now is loose, I think. I need to see if anything else holds this in place. Yeah, looks like there's another stud here. That one. No, possibly nothing there. I think there is a stud here, you just can't see it very easily. Yeah, it says it's moving now, yeah, can you see it? Okay, so this should all come out now, I think. We need to figure out why these transistors went short. Now I've taken the heatsink off, we can check a couple of things. Although it's not related, we might as well check this transistor anyway on the standby supply. So we'll just do this while we can, it just makes sense to do it. I have no reason to expect there's a problem with it, but you never know. Okay. Let's check that. Oh, well, maybe there is a problem with it. It seems to think it's just a diode junction. Just make sure I've got a good connection to it. I haven't got a bad connection maybe. Here we go. No, it's a transistor. I didn't think there would be anything wrong with it, to be quite honest. Okay, that's what I expected. So we can put that on one side now. So regarding the why the transistors went, most likely reasons are a problem with the drive to the transistors, which is this transformer I was discussing, or a short on the output. Short on the output we can test very easily. So we can go onto the ATX connector into the black, and then we can just check the various power rails. Well, that's the 3.3, but actually this often reads quite a low resistance, but in this one 7.7 is rather low. But that would be at 3.3 volts, that would be about half an amp. So it's possible there's some power resistor on here which puts a load on this to help with stabilization. Okay, 12 volts, that's reading okay, just climbing up. 5 volts, reads okay. So the only thing, well, yeah, 45 ohms, I mean, it's a bit lowish, but again, there could be some sort of load on it deliberately. I'm just looking down here now just to see if I can see anything obvious for that. Okay. I don't specifically see anything. We could check the diodes which are on here, but let's just come back to this side first. So we have this bit of a circuit down here, and this is where I mentioned that these small capacitors, if they fail, can cause these transistors to blow. There's also some diodes down here. So let's just check these, and then I'll show you on the schematic what this basically is. We have a few diodes here, so let's check all of them. That one reads okay. You can get a connection on it. I think this one probably is okay. Yeah, reads okay. The small ones here reads okay. Another one here reads okay. There's some resistors. Let's have a quick look at them, but they don't look distressed. That one's reading quite low, 3 ohms. Is this one about the same? Oh no, that reads much higher. We can have a look at that. There's another one here. That's much higher. So we have like one resistor here with a low reading across it. We can look at that. And we have a couple more looks like they go back here, hard to get onto them. Yeah, these two down here, these look like they are low value resistors. They're either 10 ohm, probably is 10 ohm, and this is probably 5% or something, the green. It read about 10. Let's have a quick look from the other side. So it looks like one of them is here, reading 11 ohms. It's close enough. Another one is here, reading the same. So I'm fairly confident they're okay. The other one that read low is this one, which reads 3.4 ohms. What's this? Oh, that's a low value resistor. I can see the gold stripe on it. So this is like 2.7. Yeah, the gold's like 2.7 ohms. That's exactly what we'd expect it to read. The capacitors, we will have to take them out, and the diodes will read okay. Here are the capacitors: 10 microfarad, 50 volt. These are not low ESR capacitors, at least I don't think they are, but they should read a reasonably low ESR. Let's have a look, and the capacitance should be correct. Okay. Yeah, 1.982. That's sort of what I expected. Other one. Same sort of reading. And we will just check the capacitance as well. Just make sure they're okay. But it's looking good. Okay. 10. 10. So we can put those back in, they're okay. It looks like all that part of the circuit is okay, but I'll just show you now on the schematic how this looks for future reference for yourself. This is a fairly typical ATX power supply of this type. I will actually link this in the video description so you can have a look. They won't all be the same, but this is pretty close. So this one has a TL494 chip and an LM393. This one's effectively a dual comparator, monitoring the various voltages. This one is the pulse width modulator, so this drives the main switching transistors. If you have a look, you'll see this is the primary of that transformer I was showing you. And these are the two transistors that I mentioned. I said one may be NPN, one may be PNP. In this circuit, they're both NPN. One is being driven from here on the base, and the other one is being driven from here. And these basically drive either end of these transformers. You'll see the little dot, this effectively shows you the start of each winding, so you'll see they're actually in antiphase. So on this one, the start of the winding is going to the transistor being switched, and then this one, it's actually, if you like, the end of the winding that's being switched. So this will effectively, by switching them in turn, cause an alternating voltage here, and that will cause these two to switch on or off. These are your main output. And again, you can have a look at the base via some resistors, and the capacitor is driven by this coil, and the other one will be driven by the other coil there, okay? And this is the capacitor that I mentioned, which tends to fail. So if you have shorted transistors here, you need to check the diodes, you need to check these capacitors. And on ours, they look to be okay. So this still leads us to the question, first of all, has the short gone away? Well, we can test that on the board with the multimeter. But the other thing I want to look at is the outputs. So these are your outputs. You can see typically this has 100 ohms, 100 ohms, 270 ohms. This has like 15 ohms on the 3.3, like a load effectively. And I've seen quite a low resistance here, which could be okay. It's not short. But I would like to test at least all the diodes and see if I have any shorts here on the output. Because so far I haven't found any reason why these two transistors went. And to be quite honest, sometimes there isn't any reason other than the fact that they just packed in effectively. Okay, so here is the output side of our power supply. We have some capacitors. This one looks like it's bulged, possibly failed. That's on the 3.3, and yeah, another one there. So we have some bad capacitors here. The other ones look visibly to be okay, at least. Certainly these two need to be changed. I don't see any particularly high powered resistors. I mean, there's one here. So these effects, I think, will be loading the output voltage rails. Let's check the diodes though. So the diodes will be on this heatsink. And they're probably 3-pin devices, like a double diode, similar to the one we looked at on the PFC. So I have the meter on diode mode. Let's have a look what we can see. Well, we have something that looks like a diode here and probably one here as well. Yeah. No short. These two are probably connected to each other, yeah, either end. And then this is, if you like, the other end of the diode. So when you see the two ends connected together, that's just the winding, which looks like it's here on this transformer. Looks like another one here. 1, 2, 3. Then this one looks like it could be short. Okay. Looks like we have a short circuit diode there. In this case then, I need to take this other heatsink off. This looks like it won't be particularly easy. There are two devices down this side, 1, 2. And we have more along here, but we're going to have to take this off. It'll have to come off so we can diagnose this further. I unsoldered this exactly the same method as that one, so I didn't bother to show you again. This had 4 devices on and 4 legs holding it in place. So a bit fiddly to get down there, but it came off just as well as the other one. So these are the diodes. You see there's a double diode symbol, common cathode there. This one, yeah, you see the double diode symbol again if I just tilt it in the light. Okay, and we have another one, and we have another one. I'm sure it is a double diode. Yeah, you can see them better now. Okay, so we have 4 of them. Let's check if any of them are short. Meter in diode mode. Should be a diode junction. Diode junction, they read quite low because these are Schottky diodes. Okay, another one. That one is not a Schottky diode, it's like a fast rectifier or something. The one fast silicon rectifier, I think the ones read about 0.4. Here's another one. 255, 256, this one. So none of these are short, so all the diodes are okay. Let's have a look again on the output of this, if we can see these low resistances. While I'm at this, under here there's some more diodes, might as well check them. Well, actually that one reads open. No, it reads like a diode. Another one. Reads like a diode. Okay. This one's on the standby. Yeah, let's see what we've got on the outputs now. Okay. Resistance range. So 45 ohms on the 5 volt. Very high on the minus 12, I think that one is, or minus 5. Here's another one. The negative supply is very high. We still see there's low resistance on the 3.3, but I'm pretty sure that will be a resistor down here. I'll see if I can find it. Could be that one. And the 12 volt. Yeah, it's quite reasonably high. So I think it might be this resistor that I can see on the 3.3. Yeah, there it is, 7.8 ohms. And the resistor is marked 7, yeah, violet, green, gold, so that's marked as 7.5. So that actually is okay, and it's that I'm reading. I need to change these 2 capacitors at least, and I need to see if I have any suitable transistors for this. Here are the other capacitors, more of these Kung Fu ones. 2200 microfarads, 10 volts. These are visibly gone. They're bulged on top, so we can just change those. There's no point messing around with them. If you look at the other ones, they all look okay. Doesn't necessarily mean they are, but I'll happily take a chance with them at the moment. So let's replace those. I have some 2200 16s. We can put these in. They'll work just as well. These are low ESR capacitors. These are new ones. I've tested a number of them before. They always test okay, so I'm quite happy to trust these now. Okay. There are our capacitors replaced. We'll just have a check now for shorts on this again. I can't imagine there will be any, but we can have a quick look. So this is where the transistors were. Okay, just go on to continuity. This is where the standby MOSFET was. Looks okay, we know the device is okay. This is where the shorted transistors were. Reads okay, reads okay. So that I think is good to go now. We just need to get the replacement parts. We also know that these devices read okay on the PFC, so that's fine. The wires eventually all fell off, the stiff wire, but I can soon sort that was out. I know where they go, I know what they are. The switching devices for the main power supply then, these are faulty. 2SC3320. Let's see if I have any of these. No, I don't have actually. I think I'm not in a desperate rush to fix this. This is mine. If I get it working, I'll keep it as one for testing motherboards and such like with. So I can just order some of these, I think, from AliExpress and get a few in stock. Let's have a look. There we have another one then, waiting for some transistors. I think I checked everything that was reasonably checkable in that circuit to see why the output devices failed. It's possible that somebody just connected too high a load to that power supply, maybe. A new graphics card that just drew more power than it could supply. There was no other obvious reason apart from a couple of failed capacitors, 3 of them. Possibly the one in the PFC might have caused it to fail, although I'm just trying to figure out by what mechanism that might have occurred, because that capacitor effectively was in parallel with the main capacitors, the 2 large bulk capacitors. But I couldn't find any other reason, so parts ordered, every chance that'll be working. Let's put it together on another video when the stuff arrives and let's see. If it doesn't, we can investigate it further. Hope you enjoyed that one anyway, guys, and I'll see you all soon on another Learning Electronics Repair video. Ciao for now.